This is Mr. Martin. These are video notes for Pre-Calculus Advanced. We're in Unit 7. This corresponds to Section 7 in your book, Chapter 7. And we're going to be working on solving trig equations, which is something that we've done a little bit before. We're just going to cover it in much more detail in this section. So before we get started, I'd like you to pause the video and go ahead and work on these three warm-up problems, just a little bit of practice solving a few different types of equations. We're going to use the same techniques that we use to solve these equations when we solve trig equations. We'll just have an additional step towards the end when we're solving. But this will give us a good warm-up, so go ahead and pause and work these out. And then when you restart, we'll have the solutions, and I'll discuss those a little, and if you have questions, make sure you ask when you see me in class. So go ahead and pause now and work these out. Okay, so here's the solutions to these three problems. In number 1, the solution is x is equal to 3/4, and the techniques that we used were subtracting the same thing from both sides and dividing both sides by the same thing. We'll use these exact techniques when we solve trig equations. Same thing over here with number 2, subtracting and then dividing. The only thing here is we end up with the square root of x is equal to -2/3, and there's no way to take a square root of a number and get a negative number. We could do it with imaginary numbers, but not with real numbers, so we would have no real solution here. And then for number 3, there would be a couple of different options to do this. One of them might possibly be factoring, but in this case it's easier to isolate the x on one side by adding 32 to both sides, dividing by 2, and then taking the 4th root. And notice here that I've got plus or minus 2 because positive 2 raised to the 4th would equal 16, or -2 to the 4th would equal 16. And we'll come across a lot of problems when we're solving trig equations where you'll be taking the square root of both sides, and it's going to be very important that you have a positive answer and a negative answer. Otherwise you'll end up with only half the solutions. So for example 1, you'll notice that there's two parts, A and B. We're looking for specific solutions over a specified interval. So for many of the problems, we will be looking at the interval of 0 to 2 pi. That's one revolution around our circle, or if we're thinking about it in terms of a graph, that would be 1 period. And then we're looking for general solutions. So these would be all the solutions that exist. And again, if you think about the graph of a sine function, it goes on forever. So we would want to find all angles. We're looking for all angles theta, where the y-coordinate is √3/2. So let's take a look at what this is on a unit circle. So sine of theta is √3/2. So we're trying to find angles where the y-coordinate is √3/2. And we know that pi/3 has coordinates 1/2 and √3/2. So pi/3 has a y-coordinate of √3/2. So as I go around the unit circle one time, are there other places that have a y-coordinate of √3/2? So for part A, one of our answers is going to be pi/3, and were you able to think of another spot on the unit circle that we would also have a y-coordinate of √3/2? Well, if we look over here, this would be 2 pi/3. It would also have a positive y-coordinate of √3/2. So that would be an additional answer. So as I go around one full revolution, at pi/3 and 2 pi/3, both of those angles have a sign of root 3 over 2. So these would be my specific solutions over the interval from 0 to 2 pi. Now if I look at this in terms of a graph, here's one period of the sine curve that corresponds to 0 to 2 pi, and pi over 3 would be somewhere around here, and 2 pi over 3 would be somewhere over here. And if I looked and determined what y-coordinate was there, we'd have the same y-coordinate over here. This y-coordinate is going to be root 3 over 2. So these two spots over that full period would have a y-coordinate of root 3 over 2. So now for part B, we want to find all solutions. So for part A we have one period, but what if we wanted to find all solutions? So here's the one period that we found them for. Let's just draw in another period, for example, or let's draw one more period this way. Okay, so we had these two spots. Here's our root 3 over 2. And every spot where this intersects my graph would be a possible solution. This was my pi over 3. This was my 2 pi over 3. And then we'd want to figure out where all of these other spots would be. So every time I drew another period, I would have two more solutions. So coming back to our unit circle here, I know I'm going to have a solution at pi over 3. So theta is going to be pi over 3. And let's disregard this 2 pi over 3 for a second. So if I'm at 2 pi over 3, and then I go around my unit circle one more time, I was at pi over 3 and I went around another 2 pi. So I went around 2 pi one time, so that would give me, we know that 2 pi is 6 pi over 3, so that would give me another solution at 7 pi over 3. And then if I went around again, that would give me another solution at 13 pi over 3. One more time would give me 19 pi over 3. So every time I go around 2 pi, I would get another solution. So I add this k value there, where k is an integer. So I'm going to go to pi over 3, and this tells me every time I rotate 2 pi, k times, so 1 time, 2 times, 3 times, or I could go -1, -2, -3 times. I'll end up at another one of these spots that's on the front side of that first hump of our sine curve. So that will give me all of these. Now I have to figure out how to get all of these. So why don't you go ahead again and pause the video and see if you could figure out how to write another equation to get all the solutions for these other spots. Let's just highlight those. This one, this one, this one, all the ones that correspond to the position of the 2 pi over 3. So pause the video, see if you can figure that out. When you restart, we'll have a solution there for you to check. Okay, so for 2 pi over 3, it would be the same thing. We're going to go around a full revolution k number of times, and that'll give us all the highlighted solutions. This next solution here would be if I added 2 pi once. This solution here would be if I added 2 pi times -1. So we can get every spot on that graph that corresponds to that. So make sure that you look at the directions for the problems to see if you need to find the specific solutions like we did in part A. As we go around one revolution, there's only those two solutions. Or if I want the general solutions, in which case I want you to write equations that give us every single solution possible. Alright, so I'm going to go ahead and end the video here with this example. Why don't you go ahead and see what you can do for the next example, and in the next video you can check your solutions to see how you did. So we will see you over there.